Assalamualaikum and hi to everyone. Today I would like to present on my final year project which titled Characterization of Nanosilica as antifogging coating Yasu method. My name is Sharifah Shazwani, 26 exam, and while doing this research I was assisted with my supervisor named Associate Professor Dr. Nurazlina. Fogging. Fogging is a natural phenomenon that usually occurs when there are presence of humid air and when there are interchangeable temperature between cool to hot temperature. When this happens, the water vapor in the air will convert into a small discrete liquid on the glass surface. The figure shows the example of fogging phenomena on the glass surface and on the eye protection glassware. In optical application, it required the surface of the application to have high transparency. Due to that, it is very crucial for the anti-fogging coating that can retain the hydrophilic properties during the application. Main properties that need to be controlled is to have a good wetting behavior, which is the material must possess the hydrophilic properties. From the previous study, the coating is made up from the inorganic material such as titanium oxide, cadmium oxide, zinc oxide, and zirconium oxide. However, this material tend to lose their hydrophilicity behavior when they are absent of UV radiation. Due to that problem, this research is introduced the silica nanoparticles incorporated in the coating to act as a pore reforming agent and improve the wetting properties on the surface of glass upon calcination. The coating will have the hydrophilic properties with mesoporous structure. Thus, it allows the water droplet to form as a continuous thin film coating with minimum light scattering. The objective of this research is first to characterize the silica nanoparticles as adhesion in thin film coating by using scanning electron microscopy (SEM) and Fourier transform infrared spectroscopy (FTIR). The second objective is to investigate the wetting and transparency behavior of antifogging coating with and without the incorporation of silica nanoparticles through UV spectroscopy. For the research analysis, firstly, the research is done by Yang et al. In the year of 2016. In their research, they are identifying the behavior of silicon nanoparticles in terms of wetting properties and refractive index of the silica. The refractive index value will be contributed to reduce the light scattering effect. Okay, for the second research is made by the Zhang et al. In the same year, which is 2016. In their research, they are identified the synthesis method to prepare the anti-fogging coating via Sol method. This method is known as a cost-effective method. And for the third analysis is made by the Du et al. In the year of 2017. Their research is obtained the good wetting behavior, which is the contact angle less than 90 degree. However, the properties of the hydrophilic is degrade when there are presence of airborne contamination in the coating. So, as a summary, this current research is to overcome the problem of entrapped airborne contamination in the coating by having a coating with a mesoporous structure. For the methodology part, the silicon nanoparticle is characterized by using Fourier transform infrared spectroscopy, X-ray diffraction, and particle size analyzer. After that, the antifogging coating will be prepared by using Sol method. The antifogging coating will be characterized by using UV spectroscopy, Fourier transform infrared spectroscopy, and scanning electron microscopy (SEM). The further result will be discussed more in the next section. This figure is show the Sol method. First, there are the tiers ethanol, hydrochloric acid and distilled water is added into the beaker to have a metal alkoxide solution. After that, the solution will undergoes the hydrolysis and condensation process. After that, the silica nanoparticles at 0, 0.01 and 0.03% will be added into the solution. After being aged for a few days, the glass slide is a deep coat in the solution. In order to have a hydrophilicity properties, the glass slide is heated up to 450 degrees Celsius and the dense thin film is obtained, and the thin film is known as an antifoggy coating. So this is the sample of the glass slide. First is a reference, which is the untreated glass slide. The second one is the 0% addition of silicon nanoparticle to the thin film coating. The third one is the 0.01% of silicon nanoparticle is added on the coating, and the fourth one is the 0.03% of silica is added on the thin film coating. This figure is explaining about the mechanism of coating. First, the water will be dropped on the glass slide and it will have a water drop shape. After that, it will have a water attracting surface with the thin film. After some time, the water droplet will be spread in a continuous thin film on the glass substrate, and this effect is known as a hydrophilicity properties. Okay, for the result part. First, silicon nanoparticle is characterized by using Fourier transform infrared spectroscopy. The significance of FTIR is to identify the composition present on the silicon nanoparticles. So from the result, it can be seen that element present consists of silica, silanol and hydroxyl group. The silanol and hydroxyl have a OH interaction. Due to that, it will contribute to the hydrophilic properties. So from the graph, we can see that hydroxyl is in the range of 2500 to 3000, and in the range of 2000, it consists of a silica oxide group. For the 1000, it has a strong peak of a silica element, and around 500 to 1000, it consists of a silanol group. Okay, for the net result is based on X-ray diffraction. The significance of XRD is to determine the crystal structure of silicon nanoparticle. From the XRD pattern, it can be seen that there are broad peak observed at 2 theta equal to 23 degree that indicate the crystal structure of silicon nanoparticles. There are combination of broad and narrow peak that indicate that that silicon nanoparticles is in the semi-crystalline crystal structure. Okay, for the third result, silicon nanoparticle is characterized by using particle size analyzer. The significance of this test is to identify the size of silicon nanoparticles that can improve the porosity of the thin film. So from the result, it can be seen that the measured size obtained is around 174.8 nanometer. There are large difference between estimated size of silicon nanoparticles during PSA is measure the agglomeration size of silicon. To have a better analysis, silicon nanoparticles can be characterized by using transmission electron microscope (TEM) in order to identify the single size of the silicon nanoparticles. Okay, for the thin film coating is characterized by using Fourier transform infrared spectroscopy. The significance of this characterization is to identify the composition present in the thin film coating. So as a result, the element present in the untreated glass slide consists of silanol, silane, hydroxyl group, and aromatic compound. As we know, the silanol and hydroxyl group have a OH bond that will be contributed to the hydrophilic properties. Meanwhile, the aromatic compound is contributed to the hydrophobicity properties. For the treated glass slide, it presents the same composition with the untreated glass slide with addition of siloxane group. The siloxane group is identified is coming from the silicon nanoparticles. By observing the peak at the aromatic compound, it can be seen that for the treated glass slide, the peak for the aromatic compound has been reduced. Due to that, we can conclude that in the treated glass slide, the hydrophobicity properties have been reduced in order to have a better wetting properties. Okay, for the thin film coating, it's characterized by using scanning electron microscopy (SEM). The significance is to determine the microstructure of the thin film. For the first picture, it shows that they have a white precipitate on the untreated glass slide. This happened due to the impurities present on the glass slide. For the second micrograph, it shows that they have a crack on the coating. It's happened due to sample damage during the cutting process. For the third and the fourth picture, it shows that they have a agglomeration inside the coating. It's happened due to the silica is not well dispersed inside the coating. So it can be said that they have a non-uniformity of thin film coating. And by observe the micrograph trend, they are by increasing the amount of silicon nanoparticle, the size of agglomeration also will be increased. This agglomeration will affect the light scattering and will contribute to the low transparency. To identify the mesopore structure, better analysis can be done, such as by using transmission electron microscopy, in order to identify and characterize the size of pore inside the coating. Okay, the thin film coating is characterized by using UV spectroscopy. The significance of UV is to analyze the amount of light passing through the thin film coating. From the result, we can see that the untreated glass slide has around 99% of transmittance. However, the maximum of light passing through the treated glass slide is around 84 to 87%. However, it's achieved the expected result, which is the light should be more than 80%. Okay, by referring to the result from the SEM, you can see that they have agglomeration inside the thin film coating. The agglomeration will reduce the transparency, so will reduce the percentage of light transmitted. And it also happened because there are larger difference of refractive index between the thin film and the substrate. By the larger difference of the refractive index, they have a high tendency to do a light scattering effect. Okay, as a conclusion, from the finding, it can be concluded that FTIR results indicate the presence of silanol and hydroxy group that will contribute to the hydrophilic properties. And XRD results show that the silica have a semi-crystalline form. And for the PSA result, it measures the agglomerated silicon nanoparticle, which in the average of 174.8 nanometer. For the thin film, the composition present in the thin film consists of silanol, silane, hydroxy, siloxane, and aromatic compound. And for the SEM, it exhibits the non-uniformity of the thin film coating with the agglomeration of silicon nanoparticle. By the result, it can be concluded that the thin film coating with incorporation of 0.01 weight% of silicon nanoparticle display better properties compared to other. However, the result can be further improved in the next study based on the recommendations. Here is the summary of the Gantt chart for FYP2. That's all from me. Thank you.